Hello CS112, today I'll be going over Lab 8, which was to transpose a two-dimensional matrix. So what does transpose mean? For those of you who haven't taken higher level math, transpose in this case would mean to take this two-dimensional list that you're given and to make all the columns into rows and rows into columns. This means that if you're given this list as your input, you would take every single row or every single column, for instance 1, 4, and make it into a row. The column 2, 5 makes into a row 2, 5, and the column 3, 6 is made into a row 3, 6, and it should work both ways. So if you're given this list instead, the row 3, 6 should be made into a column 3, 6, the row 2, 5 should be made into a column 2, 5, and so on and so forth. So these input and output should be reversible, and if you don't understand what I'm talking about, I will show you at the end. So I went ahead and paraphrased the assumptions because the assumptions were very important for this assignment. First of all, you can be guaranteed that A will be a 2D list, but you cannot assume that it will be rectangular. And it continued saying it's a rectangular matrix if and only if you guys the sublists are the same size, essentially is what it said, which is exactly how you would check for that. So I think that was pretty straightforward there. So let's come up with our algorithm. So the first thing we should do is check if the matrix is rectangular. Check if valid matrix. The reason we should do that first is because if it's not rectangular, you will not be able to transpose it and you'd run into error with your code. And also, you don't want to you can just return invalid matrix or whatever your GTA told you to return without proceeding into your code and taking unnecessary steps to make it the most efficient it can be. After that, we need to create our new answer list, the list that we're going to return at the end. So create new list. Some of you guys were trying to do some in-place switching and modifications. We did not anywhere say you guys needed to do that. That would be a lot more complicated than just creating a new list and appending to and working with that. Finally, if you guys haven't already guessed it, we need to use a nested for loop. So we are working with a 2D list, which means that we most likely need 2 for loops, and also just the overall nature of how you need to take this this column and make it into a row should sort of scream nested for loops at you. And the reason I'm using a for loop is because we're working with a container, in this case a list, and that's the easiest, in my opinion, to use for when iterating through a list. And we need to repeat that. So let's take a look at the very first thing we need to do in our algorithm, which is to create a to check if it's a valid matrix. Now, as it said in the assignment specs, that all the sublists have to be the same size. So as you can see, the length of this sublist is the same as this sublist because they both have the length of 3. The easiest way you can do this is by creating a variable set to the size of the very first sublist. The reason we're choosing the very first sublist is because we don't actually know the size of the sublist we're creating. So you can't like set it equal, let's say, 1 or 3. The safest bet would be set it equal to the sublist at index 0. So the way we do that, let's call it the master size. So we know that this is what our size is supposed to be, to the length of A at index 0. So now I've set the length equal to this, so this will be 3. Let's say we had a couple hundred sublists in here. It will check every single other sublist. Well, it'll also check the first sublist, but it will check every single other sublist and make sure it is the same size. If it's not the same size, then it will return either an empty list or a message saying invalid matrix or whatever your GTA told you to. So let's iterate through the very first, or let's iterate through A, which is the index or the matrix that we are given. So as I said before, if the master size does not equal the length, which is the size of AI, which is the specific sublist we are working with at the moment. I'm sure you guys remember how for loops work. Then it's going to return some of your GTA set an empty list. I'm just going to say invalid matrix. It's going to return invalid matrix, and that is all. Some of you guys started playing around with an else statement here, but this is really all you need. You can just continue now coding out here and start checking for the algorithm to transpose the actual list. The reason this is let's say I'm trying to print something out here like hello. As you can see, when given a square list, I'm going to uncomment this first test case here. So when given a square list, it will iterate through here. It will never reach this return statement, and it will print hello. As you can see, our return value is none because we don't have a return value. However, let's say I deleted 6. So now the size of this element is not the same as this. That's odd. It didn't print anything up here. That's because as soon as this return value is hit, nothing down here will run. So that's nice and efficient. So as you can see here, our return value is a string that says invalid matrix. So let me go ahead and change this back to a 6, and let's continue coding. So the next thing in our algorithm was to create a new list, which is pretty easy. You just let's make it super meaningful. Let's call it answer, because this is our answer, and let's set it equal to an empty list. So if you guys remember, as I said before, we're most likely going to need a 2D list. That's just an assumption-based, or I meant to say a nested for loop. And the reason I say this is because we are working with a 2D list, and also just based off how we have to transpose the list. So the first thing we should do is think about what our 2 for loops are going to do, because this is transposing is a special case here. So we should first look for patterns. So what jumps out to me at first is, let's say we're given this, and this is our output list down here. In every sublist, every sublist's element 0 becomes its own list. Then every sublist's element 1, or index 1, becomes its own list. And every sublist index 2 becomes its own list. So right off the bat, again, we're working with elements here. So we need to think about what our outer for loop does and what our inner for loop does. So our outer, based off what I just said, it needs to come up with a way to only iterate as many times as how many sublists we're going to have in our output. And as you can see, because of the length of this sublist here, and how all your sublists are going to be if your code runs this far, if it's a perfect rectangle, is it's going to be the length of this the sublist in your input list. Same with here. If you can see that this length is 2, you're going to be given 2 sublists in your output. Whereas if you're given this as your input, it has the length of 3, you're going to be given 3 lists as your output, 3 sublists in your output. So your outer loop should be iterating through the length of input sublist, and our inner. What does our inner need to do? That's gonna be the tricky part. As you guys probably remember, I said that you need to iterate through and grab everything one element at a time, or one index at a time. So index 0 goes into its own list, and index 1 goes into its own list. So our inner needs to append at a specific index. So append at index. So let's create this for loop. So I'm going to say for I in range length, and as you guys remember, we want to iterate through the first index, or the size that we're working with here. So I'm just going to literally set it equal to the size of one of these subarrays. So that's how we're going to figure out how many lists we need in our output. Now, if you guys remember my previous video on creating a 3D deep copy of a list, we need to append lists to our answer list that we initialized in order to return a 2-dimensional list. So here I'm going to, let's just call it row, because that's kind of what we're working with here. That's pretty meaningful. Now, this for loop is all it's doing is appending at a specific index. Spelled inner wrong, that's interesting. Alright, so what we can do here is say for j in a. Now this is a very simple for loop right here, but it does a lot. So I'll just work with it a little bit, and you guys can probably figure it out on your own. So let's print j and see what happens. J is a specific list here in a, right? Every element in j is going to be a list. It's printing out a bunch of times. So what are we doing with j? We want to append to our row, we want to append j at index I, right? Because I is going to iterate through all the 1s first, and then it's going to iterate through all the 2s, or the second elements first, and the third element, so on and so forth. So we're going to print ji now. So you can see it's accessing the actual elements. Let's see if this will work. Let's row.append ij, and if you guys remember, once that is done iterating, in order to save our work, we want on the same indentation as the initialization of it, we want our answer list to append row, so we don't lose any of our work when it comes back out in the for loop and empties itself again. So now that we've done that, that should be the answer. Let's go last and no errors. So I'm going to print out answer. You guys should have returned answer at this point, but I'm going to print it out, and yes, we get the correct answer. Now, as I was saying before, our inputs and outputs should be interchangeable. So as you can see, this was the input and this was the expected output. I should be able to make this guy down here, which was our output of the original equation, and get the input of the original equation, which I did. So they should be irreversible. So really quickly, to go over this again, first I iterated through the length of a sublist, because that's how many, the length of a specific sublist in your input is going to be how many sublists are in your output. So the length of 3, you have 3 sublists, and vice versa. Then I created a row to append, or a list row to append the specific values I actually needed at a specific ji. Ji was the specific index that we needed, because as you guys remember, every sublist index 0 became 1, and every sublist index 1 became 1 in a list. So yeah, this was a pretty straightforward assignment, especially if you guys fully understood what transposing was, so I don't think this one was too bad.